Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 24, volume of a right prism. Now we're really getting into things. We had area, then we had surface area, then we had all kinds of different things going on. Now we're talking about three-dimensional figures and what will go inside of them, which is volume. So, exploratory challenge starts out here. So don't be scared off by the word challenge. A lot of students see that and say, do we have to do that? Yes, you have to do that. Alright, so measuring a container's capacity. We have a box here in the shape of a right rectangular prism. It has a length of 12, a width of 6, and a height of 8 inches, and it's all labeled for us. The base and the walls of the container are 1/4 of an inch thick, and its top is open. So it's like an aquarium, actually, okay? And they're telling us this width is a quarter. So if you picture 1/4, each end, if you subtract a quarter from each end, well, 2 times 1/4 equals 2/4, and reduce that to 1/2. So we're losing a 1/2 inch inside each way. So 12 inches minus a 1/2 inch is 11.5 inches. So my new width will be 11 1/2 inches. So I'm just going to write all of the insides below. Alright, so can't write today. 11 1/2 inches. Okay, so then if I take a quarter from this side and a quarter from this side, that's subtracting a 1/2 from 6. So that would be 5 1/2 inches. And then if I subtract a quarter from the bottom, there's no lid, so I can fill this to the top. If I subtract a quarter from the bottom, 8 minus a quarter is 7 3/4 of an inch. Okay? Do not subtract a 1/2 from the height. Okay? Just keep that in mind. So now we have these red values. That's what we're going to work with. I've already subtracted. These are the inside dimensions of this rectangular prism. Okay, so the next step is we want to find volume. So the first thing I always tell students is write the formula. Volume equals your base area times the height. And then off to the side, base area is represented by what the shape of this figure is. And it's a rectangle. Rectangle, it's right here. It tells you in the word. It's a rectangle. The area of a rectangle is length times width. So the first thing I'm going to do is find the base area. So I'm going to say the base area equals the length, 11.5, 11 1/2, times the width, which is 6 minus that 1/2, or 5 1/2. Okay? So my base area is 23 halves. Notice what I'm doing here, making them improper fractions so I can multiply. And 5 times 2 is 10, plus 1 is 11 halves. So 11 halves is 23 halves, and 5 halves is 11 halves. So when I multiply those, I get 23 times 11, which is 253, divided by 4. Okay, I'm going to leave that like that for now. And really what I should be writing here is inches here, so we don't forget our unit of measure at the end. So if I write inches next to all these, then finally when I multiply, inch times inch is inches squared. So there's my base area, 253/4 inches squared. And just so you can get a feel for what that is, 253 over 4 means 253 divided by 4. And 4 goes into 25 6 times, the remainder of 1, and 4 goes into 13. 4 goes into 13 3 times. 4 times 3 is 12. Subtract remainder 1. 4 goes into 10 twice, remainder 2, and 4 goes into 25 times. So that is going to be equal to 63 1/4, just to give you an idea. Okay, the area is 63 1/4 square inches. Okay, so now let's get back to our volume problem. We just found the base area. We just found the bottom. We multiply the base area times the height, and that will give us the volume. And here is our height. So I'm going to write V equals 253 over 4 inches, I'm not going to be lazy this time, times 7 3/4 inches. And I'm going to make this a mixed fraction. 7 times 4 is 28, plus 3 is 31 fourths of an inch, or inches. Okay, so now when I multiply, I get the top times the top. So 253 times 31, 253, space, 3 times 3 is 9, 5 times 3 is 15, 3 times 2 is 6, plus 1 is 7, add, okay, and then, let's see, 6, is that a 6? 3 times 3 is 9, 5 times 3 is, that's a 5, 15, 5, 6, 7, 8, 7, so 253 times 31 is 7,843 divided by 4 times 4, which is 16 inches squared. Okay, so I'm not going to show this, but this will be, 16 will go into 7,843 490 times, and it will have a remainder of 3. So it'll be 490 and 3/16 square inches. And that, my friends, is the volume of this rectangular prism. Okay, example 1, measuring liquid in a container in 3 dimensions. So this is a really tricky problem, and these are the things that we need to be able to do in math. We can't just avoid difficulty, or things would never be invented and that sort of thing. We have to be able to do these things and be able to calculate values. So in this one it says a glass container is in the form of a right rectangular prism. So there it is. So volume equals length times width times height. There is my volume formula. And when I say length times width, that is my capital B. So it's capital B base area times height. The container is 10 centimeters long, labeled. 8 centimeters wide, labeled. 30 centimeters high, labeled. The top of the container is open, and the base and walls of container are 3 millimeters or 0.3 centimeters thick. So they even did this conversion for us. The water in the container is 6 centimeters from the top of the container. What is the volume of the water in the container? So I don't care about this distance here. I'm going to omit that because there's no water up there. They're asking how much water is in the container. So right away I need to find out what the inside dimensions are to find the volume. So we have to do what we did in the prior problem, and we have to subtract the thickness of the glass. And so if we subtract 0.3 centimeters from here and 0.3 centimeters from here, that's a total of 0.6. So 10 minus 0.6 equals 9.4 centimeters. And that is going to be our new length, 9.4 cm. Okay? We're going to do the same with the width. If this glass going this direction is 3 centimeters thick and this end is 3 centimeters thick, we're losing 0.6 centimeters total. So 8 minus 0.6 equals 7.4 centimeters. Okay? So I'm going to use 7.4 centimeters instead of the 8 centimeters. I'm going to use 9.4 centimeters instead of the 10 centimeters. Now, if we're going up 30 centimeters, we are losing the value of the base. The base is 0.3, so 30 minus 0.3 is 29.7 centimeters. I'm going to omit that, but then we have to take away these 6 inches, so I'm not going to use 29.7, I'm going to use 23.7 centimeters. 29.7 minus 6 centimeters. Okay. So now I have 23.7, 7.4, 9.4. So we have all these decimals to deal with. The nice thing about the metric system is there are 10 millimeters in a centimeter, 100 centimeters in a meter, and so on and so on. So we can always just work with tenths and get rid of decimals. Okay, so I'm going to convert this to fractions, and I'll show you how we'll do that in a moment. Okay, so we're going to first start off with our equation. Volume equals the base area times the height. So I'm just going to do this all in one rather than doing the base area off to the side. Volume equals length times width times height. I'm just showing you that L times W is capital V, so I'm get confused with that. So now I'm going to substitute in my L, which is 9.4, but I don't want to use decimals, so I'm going to multiply that by 10. So I'm going to say 94, or 9.4 is 94 tenths, okay, because a tenth is 0.1, okay, ones, and then you have a decimal, and then you have tenths, and then you have hundredths, and so on, your placement after your decimal. Well, if we have 7 tenths and 9 whole, well, 9 ones is 90 tenths, so I have 94 tenths, or 9.4. So that's how I'm getting rid of that fraction, or that decimal. So 94 tenths is my length. And I want to write what my unit of measurement is every time. So 94 tenths centimeters times, so it's length times width, and my width is 7.4, or 74 tenths centimeters. And then I'm going to multiply that by the height, which is 23.7 centimeters, or 237 tenths centimeters. Okay? So there's some pretty large calculations here, and rather than just saying what they are, I will show you what I do. It's not a bad thing to use a calculator when dealing with large numbers. Okay, so I brought in the calculator, and let me move it over so I can see what we're multiplying. I'll set it right here. So I'm multiplying 94 times 74 times 237. So it's 94 times 74 times 237. And that is going to give me a really big number, 1,648,572. So I'm going to write that here. 1,648,572. Okay, and I can do the denominator without a calculator. 10 times 10 is 100, 100 times 10 is 1,000. And that is centimeters times centimeters times centimeters, or centimeters cubed. This thousands, dividing by 1,000, moves the decimal place 3 places to the left. So I am done with my problem now. 1, 6, 4, 8, and move the decimal 1, 2, 3, 0.527 centimeters cubed. That's 1,648 cubic centimeters. And that there is the volume of this aquarium, minus the thickness of the glass and the empty 6 inches at the top. Okay, here's example 2, and it says 7.2 liters of water are poured into a container in the shape of a right rectangular prism. Here they're giving us the liters. Inside the container is 50 centimeters long. Okay, so here's the key right here. They're making it easier for us. They're giving the inside dimensions, so I don't need to subtract the thickness of the glass in this problem. They could have been really nasty and had us subtract the thickness of the glass like the last problem, but they're not. Okay, so they're saying the inside of the container is 50 centimeters by 20, and it's 25 centimeters tall. It says how far from the top of the container is the surface of the water, and they're reminding you that 1 liter equals 1,000 cubic centimeters. Okay, so see how nice metric system is? 1,001 liter. Okay, all in tens. So now we're going to we have to figure out the volume that's not used up. Okay? So if I'm using 7.2 liters of water, I know how many square centimeters that is. That is 7,200 cubic centimeters, not square, cubic. So we have 7,200 cubic centimeters in here. So if I find the volume of the whole thing and then subtract this amount, that will give me what's empty. And that's how I'm going to do it. I'm not going to subtract, so I don't know the length of this. So there's a couple of ways to do this. You could find the volume of the entire container and subtract the water's volume out of it to find the empty volume. Or you could find the distances, how much this is taking up, and define that part. But I think it'd be better just to find the total volume. So for starters, we're going to use their conversion here, which I've already said. 7.2 liters, if 1 liter is 1,000, 7 liters is 7,000, and 0.2 would be 200 cubic centimeters. So the first thing I need to do is convert to cubic centimeters, because this is in centimeters and our water's in liters. So we need a relative unit of measurement. Okay, so that's done. Then the next step is, you guessed it, write the formula. Volume equals base area times height. And I'm going to explain that again. Base area is length times width, replacing the capital B. So now volume equals length, 50 centimeters, times the width, 20 centimeters, times the height, 25 centimeters. Okay? So now I'm going to say that that adds up to 50 times 20 is 1,000. 5 times 2 is 10. Add 2 zeros, you have 1,000 times 25. So the total volume is 25,000 centimeters cubed. Okay? But if I have 25 cubic centimeters this will hold, and I already have 7,200 centimeters in it, then it says how far from the top of the container is the surface of the water. So now I know that the volume that we don't know, so I'm going to say volume remaining, a little r, the remaining volume equals the total volume minus the volume of the water, 7,200 centimeters cubed. So the remaining volume equals 25 minus 7 is 18, minus 2 is 17,800 centimeters cubed. Okay? Alright, so now I know the remaining volume. So I'm going to write volume equals the base area times the height again, or V equals length times width times height. And now I know my volume, 17,800 centimeters, equals the length, which I know, 50 centimeters, the width, which I know, 20 centimeters, and the height, which I don't know, which is here. I'm going to call that H. So when I solve for H here, I should get how much distance this is. So it's going to be 17,800 centimeters cubed, I should say, equals 50 times 50, which is 1,000, 50 times 20, which is 1,000 centimeters, and this is H centimeters. Okay, so that's centimeters squared times H centimeters. So if I divide both sides by 1,000 centimeters squared, 1,000 centimeters squared. Okay, now watch what's going to happen here. This is why it's so important to write your unit of measurements. Centimeters times centimeters is centimeters squared. Centimeters squared divided by centimeters squared cancels. Centimeters cubed divided by centimeters squared is going to leave 1 centimeter remaining. 1,000 divided by 1,000 is 1, and I'm left with the height in centimeters, which is my H, and 17,800 divided by 1,000 is 7.8. Is that correct? No, it's 17.8. So move the decimal 1, 2, 3 places to the left, and it's 17.8 centimeters equals, and I won't put centimeters here, it equals H. So H is 17.8 centimeters. Okay, here's example 3. A fuel tank is in the shape of a right rectangular prism and has 27 liters of fuel in it. It is determined that the tank is 3/4 full. The inside dimensions of the base of the tank are 90 by 50 centimeters. What is the height of the fuel tank? How deep is the tank? 1 liter equals 1,000 cubic centimeters. Okay, I'm going to draw a diagram, but rather than have you painfully watch me do this with a straight edge, or maybe I'll find one online to bring in, I will pause the video here. Okay, so here's my diagram. I just stole it from the problem up above, so ignore this water down here. This red line would be this area, or the surface of the fuel that is 3/4 of the way up the side. This is more like a quarter, or not quite. This is 3/4, and I drew, this is our new surface right here, okay? So it says a fuel tank is shaped of a right rectangular prism, and it has 27 liters of fuel. So 27 liters equals 27,000 cubic centimeters. It is determined that the tank is 3/4 full, so I wrote that there. The inside dimensions of the base, again, they gave us inside. There's no subtracting required by the thickness of the material used to make the tank. So the inside is 90 centimeters and 50 centimeters. I wasn't able to erase that, so there we go, 50 cm by 90 cm. And it says, what is the height of the tank? So it wants to know how many cm this is. So it's HCM. How deep is the tank? And they also want to know how deep is the tank. Well, that's what is the height of the fuel in the tank. Oh, okay, so they also want to know the height of the fuel, okay, and the height of the tank. So I'll call that H sub F, I'll call that H sub T, or H for tank or total. Okay, so volume equals base area times height. Volume equals the base area, which is length times width times height. So the volume equals, okay, length 90 cm times width 50 cm times height HCM. The volume was given as 27,000 cubic centimeters, so I might as well put that in here. That was a given. So I'm going to put 27,000 centimeters cubed. So 27,000 cm cubed equals 9 times 5 is 45 with 2 zeros, centimeters times H, I should say times H centimeters cubed, and then we'll have all of our unit of measurement together. Okay, let's see. H centimeters. So 90 times 50 is 4,500 times H centimeters. And they're equal. So to find out what H is, we are going to divide by 4,500 centimeters cubed. 4,500 centimeters cubed. Centimeters cubed is going to cancel. The 4,500 are going to cancel. The centimeters cubed are going to cancel. And we are going to get H all by itself here. and 27 divided by 45. And that is 0.6. Okay, so this is going to be 6, 0, or 6.0. So I had 0.6, but there's one more 0 on top than on the bottom. Now I've moved the decimal one place to the right, so I don't need the 0.0. It'll just be 6. Height is 6 centimeters. Okay? Actually, if I didn't have a centimeters here, 90 centimeters times 50 centimeters times height, and then I'd have a squared here, and a squared here, and a squared here, and centimeters cubed divided by centimeters squared is centimeters there. That's a little bit more precise. So my answer is the height of the container is 6 centimeters. Okay, now is that the container or is that the liquid? Well, that's including the liquid, so we set it equal to the liquid. So this now is 6 cm. Okay? Now think about the question. It says it's 3/4 full. So the height equals the height of the liquid plus the empty height. And 6 is 3/4 of what number? So 3/4 of H equals 6 cm. And I want to find the new height, so I'm going to multiply both sides by 4/3. And these 4's cancel and these 3's cancel, and I get the height of the tank. So here's what I should have here. This is the height of the fuel. The height of the tank is 24/3, or 8 centimeters. Okay, so there are the two answers. Alright, the height of this is 8 centimeters. 3/4 full would mean that we have 6 centimeters of fuel. 6/8 is equivalent to 3/4. Okay? And that's the end of lesson 24. Go do your problem set.